Welcome, everyone. I'm going to be hosting a recorded live lesson here in which we're just going over the Unit 3 review, but there will not be a live lesson for this. It's just the recording because we have Cambium testing this week. So I'm going to be going through the the Amplify activity. Now, I do encourage everyone to click the activity to follow along. I'll tell you when to pause and just work on it, but we're just going to go through and answer the questions so that way we are prepared for the test, which you have on your planners this week. So let's go ahead and just run through this. It should be a pretty short lesson. You'll have the opportunity to extend it out by pausing to work on the questions yourself before seeing the answers to them, but this way you'll have a good idea of some of the problems that you'll see on the test, right? So, okay, to start, we have a right triangle that has a hypotenuse of length 15. We're going to draw this because, of course, everyone knows I like to draw them. It makes it a lot easier to make sure you know what you're doing, right? So the hypotenuse is going to be the opposite of my right angle, and it has 15 as the length, and it has an angle of 50 degrees. Let's just put this one down here as 50 degrees, which a side opposite this angle. So again, since I labeled this one as 50 degrees, we're going to go ahead and label my triangle. Opposite, hypotenuse, adjacent. Again, this is my reference angle of 50 degrees, so due to the reference angle being that bottom right, the adjacent side is going to be next to it, right? And the opposite is going to be the side not touching it. Alright, so the opposite, this has a length of 9. And there's a second right triangle. So we're basically going to have two similar triangles, right? Has a hypotenuse length of 45. And what would be this opposite side. So all we're doing here, we actually probably didn't need to draw this out like I did, but it's helpful, is we're going to look at the ratios, right? These are going to be similar triangles since they both have 50-degree angles. They're both right triangles. We know from last semester, the angle-angle postulate, that these two are going to be the same as far as the ratios. So 15, 45. If I want to find out that ratio, I can just divide it, right? 45 divided by 15 equals 3. So I know that my second triangle down here is 3 times larger than my first triangle. So if this side was 9, to get that opposite, I have to times it by 3. 9 times 3 is 27. So I know that this opposite side, because of the ratios, is 27. Not too bad, right? Okay, for this one, if you guys want to pause it and work on it by yourself for a minute, and then we'll go through it. So I'll give you a second here if you want to pause. Okay, if you're returning now, I'm going to go through and solve this one so we can see it. So we are going to follow this 30, 60, 90 rule. Now, if you remember, that rule is written down here, right? We have, we see that the side opposite the smallest angle is our x. That's our, you could say, for the ratios, right? That would be like 1 unit. Whatever the hypotenuse will be double that. And whatever the side opposite the 60 is, it's going to be whatever that smallest side is times the square root of 3. So if we go ahead and draw out a triangle again, let's go ahead and do this. A, B, C, and we see that A and B is 6, B and C is 6 times the square root of 3, and AC is 12. So the second right triangle, so that's going to be our first one, right? 30, 60, 90. It has side lengths of 8 times the square root of 3. Just draw them in. 8 and 16. What would be the ratio? Well, here we can just take a look and again, it says the ratio, the side opposite angle C. So if this was C down here, if this is C, right? The side opposite of that is 6. And this side opposite of that is 8. It says, find the ratio of the side opposite C to the hypotenuse. To the hypotenuse. So 6 to 12. So, and then it says, use this ratio to identify the location of point C in the second right triangle. Okay, so we know that 6 to 12 is going to be a ratio of 2, right? We can double 6 to get to 12. So we're going to say the ratio of the opposite side of the hypotenuse is 2 over 1. And point C prime is opposite side, the length that has 8. Oh, there we go. Oh, just kidding. Let's see why that one's wrong. If we read the other ones. The ratio of the opposite side of the hypotenuse is square root of 3 over 2. Hold on. Does it let me... Let's move that slightly down. I was like, I can't get to that last part. Okay, here we are. So it is 1 to 2 because we were looking at this ratio. I mean, it's the same as the top one. I was saying it's double it, right? But it's saying the ratio of the small side to the large side. So this is 1 over 2, or 6 over 12. So I pull up my calculator, right? 6 over 12, would kind of reduce to 1 over 2. So reading that correctly, right? We see that we want to be careful on these. That's why it's so important that we're reading these questions carefully. On the test, you can easily make those mistakes, right? So if it says the ratio of the side opposite to the hypotenuse, that's 6 to 12, right? Or 6 over 12. Then the side opposite's 8. So we had, it's the same answer as the first one as if we read it backwards, right? But it is still a ratio of 2 to 1 or 1 to 2 in this case, because we're looking from the smaller to the bigger. Okay, let me make this adjust it a little bit there. Okay. We still have to adjust it now. So just a reminder here, this is and this is good for the test, right? You can use this on the test. It's also on your formula chart, but this is your SOHCAHTOA. So just a reminder of what this is telling us. It is telling us that our sine, right, is equal to our opposite over hypotenuse. That's the SO. Our cosine is equal to the adjacent over the hypotenuse. That's our CA. And then TOA, tangent, is equal to the opposite over the adjacent. So that's why we kind of write this out. SOHCAHTOA. I guess I could have used all capitals there, huh? But we have SOHCAHTOA to remember it. But typically, you can just look at this, right? You don't have to memorize it. If you guys have been doing all the practices, though, it's probably ingrained in your memory by now. But just in case you get that test, and it's like, make sure it's not hypotenuse over adjacent, it's adjacent over hypotenuse. You have the reference to look at that. So just kind of remember that. Okay, let's take a look at the next slide. So here, you could pause it, take a minute, try it on your own. Once you think you've got the answer, go ahead and unpause it, and check with my work. Okay, I'm going to go ahead and start working this one out. So a lighthouse operator is sending signals to a ship. So let's go ahead and kind of draw this, right? We have our lighthouse building here. So there's its light, I don't know. So it's sending signals to a ship. Here's our ship out here. With a 17-degree angle of depression. Now, if you remember from one of our lessons, the angles of depression means we're looking at the angle going down, right? From like if we were to look at this as a lighthouse looking straight out, the angle going down, right, from that is 17 degrees. The height of the lighthouse is 40 feet relative to sea level. So we're just going to say that's 40 over here. Which of the following correctly applies the sine ratio to find out how far away the ship is from the top of the lighthouse? Since we're looking at the top of the lighthouse to the ship, we're basically saying what is the hypotenuse, right? Or this angle here, or this side here. Now remember, this is saying the sine ratio, right? So, well, we'd have to apply that. Technically, we'd be doing the cosine. We wouldn't be doing that on this one, right? Because it says it's 40 degrees. So let's go ahead and solve that out, though, in our calculator. And make sure I'm moving that calculator so we can see my work. Okay, so if we're looking at this as the cosine, because we'll make sure, hopefully we've changed a lot of these problems on the practice just to kind of mix them up. And so sometimes, rather than, like it was originally a sine problem, but we changed it to a cosine problem, but didn't change the wording in the problem. So on the test, there won't be those errors. But when we're going through these practices, we're rewriting them every year. Sometimes, make those mistakes. Okay, so the cosine is equal to, and it should be the cosine of 17, right? I'll put that in there, is equal to the adjacent side, which is 40, over x. Now, one of the things I tried to advise you guys is the x is high, you multiply, if x is low, divide and go. Meaning, if I was to like rearrange this for x, I had to times both sides by x, cancel that out, then divide both sides by the cosine of 17, cancel that out, and so you're left with x equals 40 over the cosine of 17. So this is what we mean by divide and go. I just take whatever that number is over here, if it's on the right? If x was high, I would have taken 40 and multiplied it. Since x is low, I'm going to take 40 and divide it. So I have 40 divided by, that's just a shortcut. You don't have to work on all the math, because just if x is up top, you're multiplying it. If x is low, you're dividing it. So divided by cosine of 17. So, okay, yeah, so this problem was written where this 40 should have been identified as, like this should be our angle of elevation down here from the boat, not angle of depression from the lighthouse. So, let's see if we switch that to the, it was just written wrong, sine of 17. There we go. So same thing if we had that here, it'd be opposite over hypotenuse. If we did use the sine, right, it'd be the sine of 17. But yeah, this should have been written as a 17-degree angle of elevation from the ship to the lighthouse. Because otherwise, we're not looking at that correctly, are we? Or we could look at this angle of over here. It would be mirroring it. But it was written very poorly worded there. So that won't happen on the test. But I guess the hint was they're telling us to use the sine function. So if we put in that sine function, we get over here 136.81. And we want to round it, so 136.8. Make sure you guys are careful on rounding to the nearest tenth if it asks you to. If it rounds to the hundredth, the whole number, because on the fill in the blank answers, which there's a few of them, it'll mark it wrong if you don't put in the right, decimal point. So be careful on that. Okay, next one, same thing here. We've got a bunch of practice problems. We've got about 8 more of these, so I'll try to go through relatively quickly, but it is, again, kind of a long review. So, if you want to pause, work on this one. Alright, I'm going to run through it, so you have your opportunity if you still want to go through it, pause, but then you can unpause to go through and see the answers. Alright, so Huang, or Huang, I don't know, is standing 14 meters from the base of a kite. So let's go ahead and say, here's a kite. Here's a string that comes down, right? And here's a guy holding the kite. So it says he's, for the base of the kite, which would mean if I went straight down and make a triangle, he's 14 meters away. Now the kite string makes a 67-degree angle with the ground. So right here, here's the kite string to the ground, right? 67 degrees. Imagining he's holding it to the ground, I guess. Now it says, find x, the length of the kite string. So the kite string would be obviously from where he's holding it up to the kite. So, in this case, we want to say, okay, if we were looking at this and we want to label, we have this would be our opposite side over here. Our adjacent is next to him. And our hypotenuse would be, where the string is. Because it would make a right angle when the kite goes to the ground. So on this, based upon the information we have, we want to say which one uses the A and the H. So going over here, is a sine is O and H, cosine A and H, tangent O and A. So since we have the A and H that we're looking at, the 14 and the X, we're going to use our cosine, right? So the cosine of 67 is equal to the adjacent, which is 14 over X. So again, X is low, divide and go. So we're going to go ahead and put in 14 divided by the cosine of 67. And we get 35.83, which, since we are running to the nearest hundredth, we see that in our answer choices. Boom. We got it. Alright. Another problem, similar like it. So again, you can take a chance to pause. It's going to be very similar to the last problem. It's a word problem you can draw out. So, take a minute, pause, go ahead and try to work it out. Pause when you are ready to continue. Okay, so we have a radio tower. Just go ahead and draw a tower here. That's 200 feet tall. And it says, how far is an observer from the base of the tower? So this will be our guy over here. And we don't know how far he is, meaning this part is the question mark, right? How far is he from the base of this tower? if the angle of their line of sight from the ground to the top of the tower, so here's the ground to the top of the tower, is 65 degrees. So we are looking at like an angle of elevation there again, right? And it says around that 50 nearest hundredth. So in this case, we are going to go ahead and label our sides again. Our hypotenuse would be the longest, opposite, and adjacent. Now in this case, as you can see, we have the opposite as 200, but we're looking for the adjacent. So we're going to be using our tangent function. So we have the tangent of 65 is equal to, now again, got to keep that ratio in mind, opposite over adjacent. So we have 200 over x. I know a lot of students get confused about how do I know if x is top or bottom? Well, it's just draw it out, right? And whichever is the opposite and the adjacent, if the x was my opposite, then it would have been on top. Since it's my adjacent, right, it's on the bottom. So x is low, divide and go, similar to we said before. So let's go with 200 divided by the tangent of 65, and we get 93.26 if we round that to the nearest hundredth. So, boom, excellent, right? Okay, next one. So this one is asking just for these kind of understanding what they're talking about with these right triangles, right? So if we had a 30, 60, 90 triangle, the shortest side is going to be opposite the shortest angle. That kind of makes sense, right? The wider an angle, the wider the side opposite would be. Kind of just open and close your hands and kind of think, right? The bigger you open up your hands and you drew a line at the end of your fingertips, that would be getting longer as you open it wider. So it's kind of just making sure you kind of get that visual sense, kind of understanding what they're talking about, right? So 30 degrees, the side opposite the 30 degrees is going to be our shortest side. It's our shortest, smallest angle. So then the longest, which is always opposite the 90, right? Our hypotenuse always is the longest. And as you can tell, it's because it will always be the largest angle for a right triangle. Because the other two sides can't be larger than 90. They wouldn't be a triangle anymore. Okay, don't really need to draw that one out, huh? Alright, so this one, we have the perimeter of a square is 8 centimeters. So here, remember, we're going to have a 45, 45, 90 triangle. How do I know that? Because if I have a square and I put a diagonal between it, that means I'm cutting these 90 degree angles, right? Because all of them would have had 90 degree angles, in half. So now I have a 45, 45, 90 here, because that would be 45, that would be 45. So this is why this is a useful thing to learn as far as, well, why do we care about these special right triangles, the 45, 45, 90? Very common. We're looking for the diagonal of a square. This is done when you're measuring many, many different things. So in this case, we know that, if the perimeter was 8, then we'd have 2, 2, 2, and 2, right? 2, 4, 6, 8. So what is our diagonal going to be? Well, we know from looking down here, right, in the bottom right corner, 45, 45, 90 is 1 to 1 to the square root of 2. 2 to 2 is going to be 2 times the square root of 2. So we don't have to actually go through and solve it. We can leave it in the radical. This is one of those on that test, if you're using the Pythagorean theorem, 2 squared plus 2 squared, and then taking the square root, you're not going to get it left in the radical, right? You're going to get this as a decimal point. So you'll probably have a hard time getting the right answer. That's why we want you to just focus on this being as, okay, when I see the 45 degrees or a square and a diagonal, which you will in the test, right? That your whole idea is just remember this, and this is on your notes. You can use this on the geometry formula chart. This ratio, 1 to 1 to the square root of 2. So make sure you keep that in mind. All right, a couple more, then we're done. So here we have another example of where we're going to see, an opportunity to, like when we have a triangle that's not a right triangle, but we draw an altitude to it, or the height, it creates a right triangle. So in this case, it says if A is 15 yards and angle C is 62 degrees, what is the height? So again, we just have a right triangle here. We have our reference angle. We're looking for, if we label this, right, this would be our adjacent, our opposite, and our hypotenuse. we're looking for the opposite, we have the hypotenuse. So we're going to use our sine function. The sine of 62 is equal to the opposite, which is x in this case, over 15. Opposite over hypotenuse. Now x is high, we multiply. So this one, I'm going to go put in my 15, and rather than dividing it, I'm multiplying it by the sine of 62. And I get 13.24. It says if I round that to the nearest yard, I'm going to round that down. You may have options of the test where it's 13 or 14. Make sure you're rounding correctly. Anything less than 5, right? We round down. 5 or above, we round up. 2 is going to round down. So 13 is our answer there. All right. Another opportunity, if you guys want to look at this one, it's going to be very similar, but we are going to have our ability to find the area. So we're going to have to use a little bit more information. If you want to pause it, try it on your own. Let you do that now. All right, if you didn't. So on this one, thinking about that last problem, well, how do I find the area? There is actually a way we could use a whole different formula, using the law of sines to find the area, but we're not going to do that. Now on this one, the regular class doesn't have this. The pre-AP, there's a similar question, but we actually don't have, we removed this one from the test, the one that's like exactly like it. So still useful to know because some of these skills are applicable to other questions. So I'm going to still solve it out for you, but just know that this exact thing we don't have tested because the law of sines is not part of our Texas curriculum. So if I drew this down to create a right angle, I could have the height. Now they're going to give me that A is 14, B is 60, so if I cut it in half, right, I have 30 and 30. And then C of the angle is 77. Now if the area of a triangle, right, is going to be 1/2 times base times height. But since we've cut this one in half, we can just do base times height. So we need to, our base down here at the bottom, right, is going to be 30. And our height is going to be whatever this is over here, this x, we could say. So in this case, we probably want to use our tangent. We could actually use either function, tangent or sine, right? Because we have two of the sides. Or we could use the Pythagorean theorem, really, if we wanted to here. So because we have that information, we could use either or. So in this case, let's just go ahead and use the trigonometry, since that's, again, what we've been practicing. But just keep in mind, you could use the Pythagorean theorem, right? Now, I'm going to go ahead and use the tangent, because it's just we haven't used that yet. And so if I'm looking at my reference angle, the tangent of 77 is equal to the opposite, which is x over 30. So since x is high, we multiply, right? And I'm going to say 30 times the tangent of 77. And now I have my answer for my height here, right? Well, that doesn't sound right, does it, though? There's no way it'd be that tall. It could be that tall. X is high, multiply. Well, theoretically it's there. Obviously, that couldn't be accurate based upon these measurements, though, could it? Because that would make it taller than my hypotenuse. So, maybe we should try the sine function on this one instead then, right? Let's try the sine, because it'd be opposite over hypotenuse. And 14. There we go. So that one wouldn't work with how we measured that out. But we could with the hypotenuse. Okay, so 14 times the sine of 77, and we get 13.64. So that is our height. So again, base times height, if I do, well, 1/2 times base times height, right? And then we could double it, but we don't need to do that. So we'll do 13.6411809007 times 30, and I get 409 if it was rounded to the nearest inch, right? So 409 inches. Again, not one you'll have to worry about on the test here, but we created that problem into a trigonometry problem. So it kind of made that useful. All right, next. We have one of those fun ones where we have an apothem. Now remember, your apothem is the distance from the middle to the center of one of the sides. So it's not the same as a radius, right? The radius is going to be the part that goes to the vertex points, but our apothem is going to be basically the height of a triangle. So remember, if we are calculating the area of the polygon, similar to the triangle, we have 1/2 times that height, but rather than timesing the base, we need to do the entire perimeter, because we're basically going to have how many triangles, right? So remember, we've got to find that essential angle. That's the first thing we do. So since this shape here, we have 1, 2, 3, 4, 5, 6, 7, right? We have a heptagon here, right? With side lengths of 3.25 inches. And our apothem is 5.5 inches. So all we're going to do here is apply our formula, which is our perimeter, which is going to be 3.25 times the amount of sides. Like we said, there's 7 sides. So we'll just put in the whole thing, right? Let's just do 1/2 times, and the apothem it gave us was 5.5 times, now our perimeter is 3.25 times 7. So in this case, we get 62.5625, and there's no rounding on that. We'll just do the whole answer, right? So that's, again, a formula that you can use. It's on your formula chart or in the guided notes, or just, again, you can screenshot it, whatever you need, write it down, but you're allowed to use that. Okay. Here's another example, right? We have, this one kind of works a little bit backwards. So this one we are given the area, and again, if you want to pause it and work it out, pause it, work it out, and try to see if you can do this one backwards. But going through and solving it for you here, we have our area is 424, yada, 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 equals, and then we have 1/2. We do know our apothem is 6.5. What we don't know is the measure of each side, right? So we don't know our perimeter. We do know that there's 9 sides, so we do know that there's 9 times some number, right? Our x. So now all we have to do is just kind of work backwards. Let's just go ahead and put it in our calculator and say, well, what's the 1/2 times, pushing buttons, times 6.5 times 9. This is going to be everything besides the x, right? Now on the other side, we had 424.125. So if we wanted to get x by itself, we needed to divide this by the question mark, or our x. So we've gotten everything else, and since we don't know the question mark, right, we're going to leave that there and divide by everything else. So here we're going to divide it by the 29.25, so that we keep x on the right side, since that's easier, right? And divide both sides by the 29.25. So I go over here and put that in my calculator. So it's the same thing as we did last time, but this time we are having to work backwards, right? We don't know the measure of each side, but we know if we lay out that formula, we just move the unknown from being the area, the unknown being part of the perimeter equation, the length of each side. And we get it here as 14.5. And if I put that in, right, that would solve the equation correctly. 14.5, and now I would get this whole answer. All right, last one. This one we are going to have to do a little bit more. Again, this is mainly going to apply to the pre-AP students. The regular, I don't think you have a question that's difficult, but working this one out. So we have a regular heptagon again. It's our 7-sided figure. And we have our apothem of 8.25. Oh, it's not too difficult on this one, actually. Sorry. I was thinking we had to solve this one out. But, and then we have our area of 184.8. And it's the same thing as that last problem. We know that it's going to be equal to 1/2 times our apothem, which was 8.25. We know it's 7-sided, but we don't know the length of each side. Well, so we're just going to go through and calculate the same thing. 1/2 times our apothem times the fact that it's 7 sides. Now we know what to divide the area by to find what each side is. So since our area was 184.8, we're going to divide that by 28.875, and we get that each side is 6.4. All right, and we've made it to the end. If if you guys have gone through and worked through this, you hopefully will have a little bit better idea of what to expect for the test. But if you have any questions, you can always stop by the tutoring. There's no rush in these units. You have an extra day on Friday, so you can always stop into tutoring and see me if you need any help.